Hey, good morning, Ag Structures class. What we've got today is a little bit of fencing math. I thought this would be good because we've learned about the mechanics of how to do the fencing. So I'm going to run through a problem that you might see, and then I'm going to leave a problem online that I want you to figure. There will be 5 questions for you to answer, plus a flashback at the top, and you'll just submit that to me for your work. Guys, if you talk to people that are in your class, check in on them and see how they're doing. This isolation thing can be kind of tough on your mental health, but also I'm not seeing a lot of work out of this class. So, this is going to be your attendance, and this is what the school is going to use as their measurement for how many students were enrolled for the day. And it's an easy way for us to get those points. Course of action: if I don't hear from people this week, I've got to start calling home, and I really don't want to allot that much time to that task. So let's try and nip it in the bud now. Reach out to folks, make sure they're on top of it, and we'll kind of go from there. Let's talk a little bit about fencing math. So let's say you're hired for a fencing job as your SAE project. And remember, SAE is that supervised agricultural experience that we encourage you to have for FFA. Looking at the job, you're going to lay out a map. So the farmer says you've got this wedge-shaped field that he wants fenced. There's going to be no gate for whatever reason. No way in, no way out. Maybe it's a perimeter fence. He doesn't want anybody getting in. How about that? Anyhow, on this particular layout, the north side is 380 feet. The east side is 295 feet. The south side measures 520 feet, and the west side measures 125. So if we go back through it, our north side's 380. We've got our compass down here. I don't know why I'm pointing at the screen, but where the mouse is, north. The east side, 295. The south side's 520. And then the west side's 125. So that south side's pretty long because it's the hypotenuse of this wedge. Okay? So what is the total perimeter of the field going back? Well, perimeter is just the total measurement of the exterior. So we could do the math together. Pull up our calculator. We've got 380 plus 295 plus 520 plus 125. 1,320 feet. Okay. Number 2, the wire that the farmers selected for this job is going to be number 9 field fence. That's a non-high tensile wire. It's very, very common for people that want non-high tensile wire. It's fairly cheap and it's easy to install. So this 330 or this number 9 wire comes in a 330-foot roll. If that we were to do the calculation, how many rolls do we need? Assuming that measurements are exact, we don't want to worry about having any extra on hand. So if we go back to our 1320, we divide that by 330, it says we need 4 rolls of that field fence wire. You guys can see this slide here. I'm not going to go back to the play. I'm just going to read it in case your screen's small. Barbed wire will be installed on the top of the fence to avoid cattle from pushing down on the fence. So that's just an installation method that we do. We don't want them to crush that wire. A lot of times they'll rub. If we put barbed wire up there, it limits the rubbing. Barbed wire comes in a 1,320-foot roll. How many rolls are needed, assuming measurements are exact? Well, if you go back to our perimeter measurement, we saw that it was 1,320. The roll of barbed wire, pretty standard, is 1,320. Says we need 1. The braces used for this job are H-style, and they're going to be made of 6-inch posts. Remember, the corner braces utilize the same post. So we have one corner, and then at each corner, we're going to have a brace going one way and a brace going the other way. How many 6-inch posts are needed? So in this one brace here, we have 1, 2, 3, 4, 5. So if we go back to our map, we have 1, 2, 3, 4 corners. So if each brace requires 5 posts and there are 4 corners, that means that we need 20 6-inch posts. Number 5, the farmer prefers the brace post to be concreted in place, which is standard practice for a lot of field fence. Concreting posts is going to require that we are hand digging them or we're using a post auger to dig those holes. Each post requires a bag and a half. How many bags of concrete are needed? Now, each brace has 5 posts, but 2 of those posts aren't concreted, right? So we are digging 1, 2, 3 post holes for each brace. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 6, 9, 12, or 3 posts times 4 corners, 12. Now, if we go back to the problem, it says we need a bag and a half per post hole. So 12 times 1.5 is 18 bags of concrete. Question number 6. There are approximately 66 fence staples per pound. How many fence staples will come in 20 pounds? So 66 times 20 pounds, 1,320. Also a pound per foot. Any questions you guys have, please email me. Work on those math problems today. I'm going to upload another problem. I just want you to answer those 6 questions, answer the flashback, and then shoot those to me via email. All right. Reach out to your classmates, check in on them. If you have any questions, you can ask them, you can ask me. We'll kind of go from there. Guys, I appreciate you. We'll talk soon. Thank you.